Welcome back, folks. Here is our first mesh analysis problem that has a current supply. I've noticed a lot of people in my career avoid doing mesh analysis whenever there's a current supply, and they use a couple tricks to remove the current supply from the analysis. And that's okay, there's nothing wrong with it. But there are circuits that have current supplies, and you can't use those tricks. All right, we'll look at what those tricks are later in the semester. But considering how easy it is to handle the current supply in mesh analysis, I don't even know why you need those tricks. So rather than being tricky, we're going to apply a fundamental law that we haven't touched yet. If you've been paying attention in our mesh analysis so far, we've only used KVL and Ohm's law. We haven't touched KCL, but that's about to change. Okay, so let's take a closer look at this problem. And hey, it's got a current supply. It's got a 5 amp on the right there, and we're gonna have to deal with that differently. So we do some things that are similar. We label our mesh currents. Okay, that's I1, and let's call this one I2. Okay, I'm going to label my polarities for my passive components inside the meshes. I'll do it over here, but what we're going to find is that it ends up not being necessary. Okay, so now I sit back and I think, and I say, okay, there's two unknowns because I have two mesh currents. So I'm going to need two equations. So I'm going to write a KVL around I1, and everything's going to work out just fine. Let's see here. So let's write our KVL for I1. And I'm going to go up 10 volts. I'm going to go down across the 4 ohm. I'm moving faster now, right? Because you're getting better at this, I hope. And then I'm going to go down across the 6 ohm, I1 minus I2. Okay? If I went too fast with that, I want you to stop, go back and watch the last videos, write it out the long way, and see that, well, I did it right, and maybe get comfortable with why I did that and how quickly I did that. We can do these in under 30 seconds if you practice. We're not even at full speed yet. Okay, rearranging and regrouping like terms, we get negative 10 I1, positive 6 I2, and negative 10 on the right hand side. That was pretty stinking quick. Okay, I like that one a lot. Now the problem I'm going to run into is with the mesh that has the current supply. Okay, so let's walk over here, and I would usually say, okay, minus VR2, minus VR3, and then there is a voltage across this, and let's call it VIS, minus VIS, and I'm back to where I started, so that's 0. And now I'm critiquing my handwriting. I can handle these two because we know the resistances, but I cannot rewrite this one. Okay, I cannot rewrite this one without knowing the resistance. Can't. Okay, rewrite in terms of unknowns. And our unknowns, of course, are the mesh currents. And that's a problem. And that's why we can't write the KVL for I2. So we got to cross it out. What do we do instead? What do we do instead? And the answer is we lean on our fundamental laws of circuit analysis. KVL, KCL, and Ohm's law. We got to reach in and we got to use KCL for the first time. And I'm going to write this once the long way so that you see it's the KCL. But ultimately, I'm going to ask myself the same questions that I did when we were writing those KCLs really quickly during the first videos for mesh analysis. How do we use the mesh currents? And we're going to take that same approach. So that skill transfers to this as well. So if I want to write it as a KCL, okay, now I'm going to write the KCL for I2. If I want to write it as a KCL, I pick a node on either side of the branch that includes the current supply. Okay, IS is pushing 5 amps into the node, so that's going to be 5 amps going in. And then on the other side of the node, I've got some current, and it looks like I2 is flowing in, right? As I follow I2 around, it's the only current that goes in there. So I can say plus I2, and that's equal to 0. That's all behind me. Let's get that up for you. Okay, solve for I2, and I get I2 equals -5. Okay, now our goal is to have equations that we put into our system that are a bunch of unknown mesh currents and a bunch of constants. And look at this one. Even though it's a KCL, it still fits that format, and I can still put it in that system of equations, even though it's not voltages and resistances and currents. It's just a summation of currents, but it still fits in that system of equations, so we're going to use that. Okay, I could have gotten to that quicker. I'll do it up here. I could have gotten to that quicker by saying, does I1 touch it? No, it doesn't, so I'm not going to write I1. Does I2 touch it? Yes, it does. Does it flow in the same or opposite direction? It flows in the opposite direction, so it's a negative. So negative I2. Okay, now once I go through all those mesh currents, I can say that's equal to 5 amps. So negative I2 is equal to 5 amps. Well, that's not mathematically any different than, grab it, there we go. That's not mathematically any different than this, right? I can just multiply both sides by -1 and it would work out just fine. So I can enter either one of those, and it's really your choice. Okay, so I have two equations and an alternate form of the second equation. I have two equations and my two unknowns. Let's squeeze it in up here. Okay, -10, +6. I'm going to invert this matrix, and the right-hand side in this case is -10. Okay, and that's going to give me I1 and I2. Now I'm running out of real estate and I'm questioning my life choices. We'll squeeze it in here, hopefully. If not, I'll slide this all over. Okay, that's the first equation, right? -10, 6, and -10. Same way we did it in the previous videos. This one is no different. What's the coefficient of I1? Well, it doesn't show up, so that's 0. What's the coefficient of I2? And in this case, it's -1, and then the right-hand side is simply 5. Okay? Pause the video, do whatever you need to do. Practice solving these systems of equations. I'm going to do it quickly in front of you with my TI-85. They stopped making them, and I just think it's a shame. It's a good calculator. All right, and we get, we're going to fit it in here, -2 amps and -5 amps. Okay, those are the mesh currents. All right. Is that all I want to do here? Yeah, so I guess find the mesh currents was really all I was doing. Find mesh currents. Because once I have those mesh currents, I can use them to go find other values in the circuit, and I think we've done that a good amount. So I've got -2 amps flowing this way and -5 amps flowing that way. Okay, so of the two cases that have current supplies, when we're doing mesh analysis of circuits that have current supplies, this is the easier of the two. Okay, the next one's not that much harder, so don't be scared of it. But the moral of the story here is, if I see a current supply, I'm going to write a KCL. Okay, so my system of equations came from one KCL, and I knew I needed two equations, So I knew I had to write 1 kVL. Okay, so 1 kCl because of the current supply, and then I make up the difference for how many equations I need. 2 unknowns means I need 2 equations. So 1 kCl, 1 kVL gave me my 2 equations. All right, we're going to do this again in the next video, but we're going to work with a current supply that's in a bit of a different location in the circuit, and it makes things a little more complicated, but you're going to handle it no problem. So stay tuned and good luck.